Welcome to PSLE Maths, where you find solutions to PSLE math problems. Please subscribe to this channel and press the bell icon for notification. Thank you.
Hello kids, welcome to part 3 of pattern problem videos. In part 1 and part 2, we have seen constant difference method and square number method. This is triangular numbers method. And as I have said earlier, in pattern problems, depending on how the number is increasing, the method has to be chosen. So let's look at this triangular numbers. The first pattern has one purple dot. Second pattern has 3. Third pattern has 6. And fourth pattern has 10. So we see the difference. It is not a constant, but it is increasing. 1 to 3 is 2. 3 to 6 is 3. 6 to 10 is 4. So when it is increasing like this, we have a constant formula for this. It is essential to know this formula just to use it even if you do not know to derive this formula at this stage. If you are aiming for 95 to 100 marks, then this formula you definitely need to know for the last section of the pattern problem. So now I'll just show you how to derive this formula. This would be useful for kids who are doing Math Olympiad. Otherwise also, it's just good enough to know the formula. So in this case, look at the numbers. It is increasing as 1 plus 2 plus 3 plus 4 and so on until pattern number n would be until n. So can we write this down as 1 plus 2 plus 3 and so on until n minus 2 plus n minus 1 plus n. So the first number and the last number, if we add, we get n plus 1, 1 plus n or n plus 1. Similarly, the second number and the last but one number, when we add, we also get n plus 1. Similarly, the third number and second last number, again n plus 1. So how many n plus 1s would we have in total? Each two numbers will form one pair, which means n by 2, the pattern number n by 2, number of n plus 1s would be the total addition, total sum of this equation. So this is what we have used in the formula. So even if you do not know to derive this, you can remember this formula for triangular numbers. So for example, let's test this number for both odd number as well as for even number. So if the pattern number 5, the number of purple dots is equal to, we know the next number should be 15. Pattern number 5, the number of dots should be 15. So n is 5 times n plus 1 is 6 divided by 2, which is equal to 15. So that's right. Let's test the same thing for 6. So after 15, when we add 6, it would be 21. So the answer should be 21. So here, 6 times n plus 1 is 7 divided by 2. 6 divided by 2 is 3. 3 times 7, 21. So the answer is correct. So let's just take a random example. The number of dots for pattern number 35. So how do we do? Just n, which is 35, into n plus 1, which is 36, divided by 2, which is 630. So there would be 630 dots in pattern number 35. Now, in this same pattern, let's look at the number of triangles. The first pattern does not have any triangle, 0. Second pattern has 1 triangle. Third pattern has 4 triangles. Fourth pattern has 9 triangles. So look at this. The increase is not 1, 2, 3, 4. The increase is 1, next is 3, next is 5. So it increases in odd numbers. Right? So this, the formula would be the square numbers n minus 1, the whole square here, Or if the number had been starting from 1, 4, 9, and 16, it would be n square. This is what we call as square numbers. So under the same question, one part could follow triangular numbers, another variable could follow a square number pattern. So for this, please refer to the part 2 of the video. Now let's look at another example where there are some cards stacked up. The first pattern has 2 cards. Second pattern has 6 cards. Third pattern has 12 cards. Here again, this increase is not constant, it is increasing. And we also notice that it is just twice that of the triangular numbers. So at the first look, it might not look very familiar. It may not be the triangular numbers, but it would be some kind of a manipulation with the triangular numbers. In this case, it is just twice the triangular numbers, which is nothing but n into n plus 1. N into n plus 1 divided by 2 times 2, the 2 gets cancelled, so it's just n into n plus 1. So let's look at an example here. Number of cards for pattern number 14. So how many would it be? 14 times 15, straight away 210 cards. So if the question is which pattern number would have 702 cards, so we just have to find out which two consecutive numbers, if we multiply, we would get the answer 702. We know 20 times 21 should be slightly more than 400. We know that 30 times 31 should be slightly more than 900. So our answer should be in the 20s. So we can do some trial and error and we get it as 26 times 27 is 702. So pattern number 26 would have 702 cards. So these are typical questions that would come in part C of the pattern problems.
Hope you like this video. Please subscribe to this channel for more problem sums. If you have a specific question that you would like to see a video on, please post it in the comment section. Thank you.